Okay, number 22 is a stoichiometry problem. It says when 75.6 grams of aluminum reacts with bromine gas, aluminum bromide is produced. How many moles of aluminum bromide are produced? So first step to stoichiometry. Well, that was a big thunder. Okay. First step to stoichiometry is to circle the two things you need out of the equation. So we need aluminum and we need aluminum bromide. Okay. Next step is to write down your given, which is 75.6 grams of aluminum. Okay. And then set up your ratio. Copy the unit from your given on the bottom. So we have grams of aluminum. And then on top, we have moles of aluminum bromide. Okay. So next step, and I can't tell you how many times, you cannot forget this next step. You have to write down the coefficients from the chemical equation. So the coefficient in front of aluminum is 2. The coefficient in front of aluminum bromide is 2. And our last step here is you need to put the molar mass of aluminum into the parentheses because it says grams. So the molar mass of aluminum is, I believe, 27, but let me check my periodic table and make sure. Okay, that's not it. Okay, Google, what's the molar mass of aluminum?
The atomic mass of aluminum is about 26.981539 atomic mass units.
I think they're making it up because she's saying 26 and I wrote down 27. They're lying. Never trust Google. I shouldn't even be Googling that. I can't see any of the atomic masses. Hold on. Sorry, y'all. I'm using my phone as a periodic table, and I didn't realize that that was not going to work out. Well, I guess Google was right. 26.982 might be different. Who knows? Okay. Then I plug that whole ratio into my calculator. So I do 75.6 times 2 divided by 2 times 26.982. And I got 2.8 moles. And that took way longer than what it was supposed to. All right, number 23. In the reaction of solid zinc with hydrochloric acid, the products of hydrogen gas and aqueous zinc chloride are produced. Which of these is the balanced equation from the reaction? Now, my very good students, they would write each equation to the side and they would check to see which ones were balanced or not. But we can visually check this. Look at A. The first thing I see is I see a 2 on the product side for chlorine and no 2 on the reactant side. So A cannot be balanced, right? Look at B. Zinc and zinc are good, okay? But I see the same thing going on with chlorine. There's a 2 here. Oh, but wait. There's a coefficient of 2 over there, which would fix the chlorine. So then the H also has a 2 on the reactant side, and it has a 2 over there. So I'm just going to put a check mark because that might be correct. If I look here on number 2, zinc 2, but over here, I don't see a 2 as a coefficient or a subscript for zinc, so it can't be C. And then for letter D, there's a coefficient of 4 in front, which means on the product side, I should expect to see a 4, maybe a coefficient of 2 times 2 or 4. So when I look here, there should be 4 hydrogens on the product side. And when I look at my hydrogens, I just see a 2. So letter D is wrong. Answer is B. Okay, which element has the same chemical properties as fluorine? This is a pretty easy question. We have to remember that elements in the same group have similar chemical properties. That's why they're in a group together. So fluorine is in group 17. So my option could be chlorine, bromine, iodine, or AT. And bromine is in the same group. So the answer was A. What is the correct formula for aluminum oxide for number 25? Oxidation numbers, aluminum is a +3, oxygen is a -2, cross drop, Al2O3. A. 26, a 200 milliliter sample of gas has a pressure of 1 atmosphere. If the volume of a gas is decreased to 50 milliliters at constant temperature, the new pressure of the gas will be. We're using ideal gas law because it's talking about how the gas changes. So our formula is P1 V1 T2 equals P2 V2 T1. Now it says constant temperature, so I get to cross out T. Okay, so my formula is P1 V1 equals P2 V2. Okay, I'm solving for the new pressure, which means I'm solving for P2. So I can move V2 to the other side. And I'm going to erase. And that's my formula. Okay, so my P1 is 1 atmosphere, it says. Let me move this to the side. 1. Volume 1 is 200 milliliters. I can change that to liters to make it a little bit more comfortable to use. Okay, that would be 0.2 liters, just divide by 1,000. Same thing here, if I wanted to change this to liters to be more comfortable, I can do that. So be careful with this one though, because 50 divided by 1,000 is 0.05. Okay, so V1, volume 1 was 0.2. And then all over V2, final volume, which is 0.05. Okay, so when I put this into my calculator, I get 4 atmospheres. And that makes sense because as you decrease the volume of a gas, you're increasing the pressure of it as well. All right, number 27, you guys got good at nuclear equations once we practice them. It says, from the following nuclear equation, determine the final product in the nuclear equation. You have to balance the numbers on both sides. So on this side, it says my top number is 209 and my bottom number is 84. I have alpha decay over here as helium. So that means in order for me to get to 84, what number plus 2 equals 84? Well, that's 82, which means I can go over here and I can immediately eliminate A and B. Okay. Now my top number, what number plus 4 equals 209? That would be 205. So my answer has to be C. Okay, so just make sure that your numbers equal on both sides of the arrow. Number 28, write the correct formula for dinitrogen tetraoxide